Hi everyone. My name is Kishore Chakravadhanula. I am product manager for robotics, drones, and intelligent machines at Qualcomm. I'm here to talk to you about how 5G and AI is transforming the next generation of robotics. Robotics is at the cusp of transformation. There are more and more unique use cases that are coming up in logistics and warehouses, at factories, in consumer robotics, delivery robotics, as well as drones, including swarms of drones. And there are three fundamental pillars that are transforming this that are causing this transformation. They are heterogeneous compute, distributed intelligence, and 5G connectivity. So, what is heterogeneous compute? It is a paradigm which matches intelligently the right processing engine for the right task. And as you know, robotics has a breadth of technologies and requires a host of processing. So specialization is key. Each processing engine has its own strengths. For example, the CPU is best suited for sequential control, while low power real time applications are better processed on a DSP. Similarly, processing of streaming and parallel data is best processed on GPUs, while ultra fast AI inferencing is better done on neural processing units or dedicated AI engines. Likewise, a hardware accelerator or a computer vision processor does computer vision capable processing much more efficiently. The second pillar of this is connectivity, and more precisely 5G connectivity. And when combined with AI, the opportunities are endless. First and foremost, 5G is much more than mobile. It caters to a host of other things like mission critical services and massive Internet of Things. 5G standards have been written to meet the unique use cases of these applications, such as vehicle to everything communication, drone communication, or meeting ultra low level latency and high availability in industrial settings, or precise positioning for various applications and such. Three of the key things that are required for industrial IoT and robotics are ultra low level latency, and we're talking about sub millisecond latency. We need high reliability for the communication network, and by that we mean 5 nines or 6 nines of availability, both on uplink and downlink transmission. And finally, high availability. That is, the network shouldn't go down, there should be fail safe, switch over from 5G to LTE and such. All these are enabled on the 5G new radio URLLC, which stands for ultra reliable low latency communication. I think this is best illustrated via the example demos that we have here. Here we have a warehouse setting where there is a robot that is that has where there's a conveyor belt on which various objects are traversing. There's a camera that captures the images of the objects and pushes it over 5G to an AI vision server, which classifies the objects and informs the PLC that is controlling the robot as well as the gates to do the necessary actions. All this is connected via transmission reception points or TRPs and a coordinated multi-point server, which I'll explain in a minute. So as you can see here, different green and red color objects are going over the conveyor belt, and the robot gets commands to either push them to left or right depending on the color. With time synchronization turned on, and what is time synchronization is nothing but synchronization of all the network components to precisely the same time. and 5G enables TSN. When it is turned on, there are practically almost no errors done by the robot. However, when you turn off the TSN, the latencies are greater than millisecond, and what is happening is you're seeing error rate as high as 25-30%. So that is a key thing there. The TSN offers sub microsecond synchronization. A second example here is about reliability. And in this demo, what we are showing is a warehouse setting where a robot is connected to multiple TRPs or transmission reception points. And because it is connected to multiple of these TRPs, even if the signal link between one TRP and the robot degrades because of, let's say, interference from moving objects or some metallic structures and such, it does not affect the performance of the robot because it's connected to other TRPs. However, if the TRP, if the robot was only connected to a single point, then the signal to noise ratio degrades dramatically, resulting in very high packet error. And thus, having multiple TRPs and a coordinative multi-point server to coordinate the data coming from all the TRPs is very, very important and fundamental to the 5G design. And by doing so, the signal to noise ratio is not affected and the packet error rate is very low and steady. This enables 5G to be a replacement for wireline Ethernet in industrial applications and 5G as a carrier for robotic applications, which need real-time processing. As you can see here, the error rate we are talking about, if you dig deeper and you can see here, the error rate we are talking about is 0.1% to 1% when URC is off. But with URC always on, it's in the order of 0.0001% or lower. So what we are doing here is seeing is 5G is able to extend applications or use cases that were possible only on the device, but by enabling the data to transmit to other places. And thus we are unlocking new use cases for the future. Taking this further a step forward is precise positioning and how 5G enables precise positioning. With release 16, 5G was able to offer accuracy levels of up to 10 meters for outdoor applications and 3 meters for indoor applications. Needless to say, this is not going to cut it for most industrial applications and robotic use cases. Therefore, 5G incorporated in its release 17 standards new technology that enables centimeter level accuracy. And we are talking about sub 30, sub 20 centimeter accuracy. And they're able to do this while maintaining low latency and high reliability. To illustrate how this works in real world setting, we can see the next demo where in a warehouse setting, you have a AMR or autonomous mobile robot mounted with a collaborative robot. The AMR is given instructions to go to a certain aisle and pick up boxes from a certain location. The precise positioning of 5G enables the robot to traverse effortlessly. And when you combine that with computer vision application that is possible with the camera mounted on a cobot, you're able to realize sub-centimeter level accuracy that's required to handle objects. This robot, once it picks up the objects, goes to the next place for further processing. And just like in the previous example, the robot is connected to different TRPs, which enables high reliability. In addition to that, the TRPs provide via triangulation technologies the precise positioning needed. And that is what is enabling centimeter level accuracy in 5G. Here is an example where a gantry is being used to map the digit 5 So what we have done here is we have given a digit 5 with various points, and the gantry is asked to map it. And we are measuring the error between the intended position versus the actual position on which the gantry mapped. And you can see on the right side charts that the error rate is most of the time below 10 centimeters and much lower than the 30 centimeter target that we have been striving for with the release 17 standard. Now, if I were to take the same gantry and ask to speed up things and do the processing in a much faster setting, as high as 8 times faster, you will see that the robot is able to do that in this example without any degradation or in performance or errors, and it's still able to meet the same standards or targets that are set for it. Thus, combining precise positioning available of 5 with 5G with computer vision enabled precise positioning can help robots in warehouses, factories, and such pick up objects and move them along and place them in the intended locations. So bringing this all together, right? We have 5G, we have AI, and when they come together to meet at the wireless edge, that is when intelligence is unlocked to open up new possibilities for all kinds of applications. So traditionally, what has happened is all the intelligence used to be on the central cloud. However, there are lots of limitations with that. You have high latencies, and transporting massive amounts of data generated at the edge is a big problem. So where we are today is we have increased the compute performance on the device, and a lot more processing is happening on the device today. However, the future is going to be distributed, and where there is a edge component coming into play, and 5G will be the backhaul that transports massive amounts of data back to the edge. And we're talking about low sub 1 millisecond latencies. And what happens here is that the wireless edge is able to do all that stuff that typically is done on central cloud, like retraining, processing all that massive amounts of data and such. And more importantly, when the data comes from different robots. And then 5G can be used to push out new commands or new data models or whatnot back to the device. Furthermore, what happens with this paradigm is that you're able to keep all the data at the edge and ensure the privacy and security. And only the sanitized data that is required for training but not sensitive data is pushed to the central cloud. And here, this data is needless to say can tolerate longer latencies. Thus, you're able to do a lot more by incorporating the wireless edge. So how do we bring this all together, and how can you realize or unlock this for your own applications? Qualcomm has that's Keeping that in mind, Qualcomm has launched the world's first 5G and AI-enabled robotics platform. This platform is a purpose-built robotics development kit called Qualcomm Robotics RB5 platform. And the kit comes with various mezzanines, which are like Lego building blocks that you can stack on each other and to expand its capabilities. First and foremost, there is a vision mezzanine which supports main camera, tracking camera, stereo camera, depth, time of flight camera, GMSL cameras, etc. And that provides vision capabilities for your robot. Then there is a sensor mezzanine which has pretty much every sensor from single and dual IMUs to pressure and pressure sensors, magnetometers, and whatnot. This provides sensing capabilities to your robot, and more importantly, you don't have to worry about integrating those drivers and all that into your robot. Then there is a motor control mezzanine, which supports almost all kinds of motors and it controls these motors via simple applications or programming. There is industrial mezzanine to meet communication requirements with industrials in an industrial setting like EtherCAT or Ethernet IP, Profinet, Modbus, etc. And last but not least is the communication mezzanine, which provides cellular connectivity, be it 5G or LTE, and also Wi-Fi for sure. Thus, what we are offering with Qualcomm Robotics RB5 platform is the ability for you to rapidly prototype, to develop proof of concepts and rapidly prototype. We have a rich chipset offering to meet every tier of robot you build and every requirement that you have. We have software tools that enable you to develop easily computer vision applications or AI applications, and also have cloud integration and such. We have hardware development platforms to help you realize this. And finally, we have a rich partner ecosystem that offers solutions to meet your end-to-end use cases for robotics and industrial IoT. And for further more resources on all this, you can visit the links shown here in this page. I hope this information and session has been very useful for you. If you have any questions, please feel free to reach out to us. Thank you very much.